Hey guys, Mr. Synthetic here, back for another episode. Today, I've chosen the topic of space travel and colonization. I'll be breaking today's subject down into 5 subtopics. Space travel poses a number of challenges for human health, including radiation exposure, weightlessness, and isolation. These challenges must be addressed in order for long-term space travel, such as a mission to Mars, to become a reality. Radiation exposure is a major concern for space travel. Astronauts traveling in deep space will be exposed to high levels of cosmic radiation, which can cause cancer and other serious health problems. Scientists are currently researching ways to protect astronauts from radiation, such as developing new materials for spacecraft that can shield against radiation. Weightlessness is another concern for space travel. Prolonged weightlessness can cause a number of health problems, such as muscle and bone loss, and can also lead to disorientation and other psychological issues. To counteract these effects, astronauts will need to engage in regular exercise and other activities to maintain their muscle and bone mass. Additionally, isolation can affect the mental and emotional well-being of the astronaut, so strategies to minimize isolation should be implemented. In conclusion, the challenges of long-term space travel are numerous, and it requires a multidisciplinary approach to overcome these challenges and to ensure the safety and well-being of the astronaut. From developing new materials for shielding against radiation, to maintaining muscle and bone mass, and minimizing isolation, scientists are working to find solutions for these challenges so that humanity can explore space in a safe and sustainable way. The search for habitable planets is a crucial goal of space exploration. The discovery of a planet that could potentially support life would have enormous implications for humanity and would open up new possibilities for the future of our species. Scientists are currently using a variety of techniques to search for habitable planets. One of the most promising is the study of exoplanets, which are planets that orbit stars other than our Sun. Scientists use telescopes and other instruments to study exoplanets and search for signs of habitability, such as the presence of water, a suitable temperature range, and the right conditions for life to evolve. The search for habitable planets is ongoing, and scientists have already discovered a number of exoplanets that are considered to be potentially habitable. However, much more research is needed to determine whether or not these planets actually have the right conditions to support life. In addition, the development of new technologies, such as the James Webb Space Telescope, will help to improve our ability to study exoplanets and search for signs of habitability. In conclusion, the search for habitable planets is a crucial goal of space exploration that has enormous implications for humanity. By using a variety of techniques, such as studying exoplanets and searching for signs of habitability, scientists are working to find planets that could potentially support life. The development of new technologies will also be crucial in improving our ability to study exoplanets and increasing the chances of discovering a habitable planet. The development of new propulsion technologies is crucial for humanity's ability to explore and colonize space. Traditional propulsion systems, such as chemical rockets, are limited in their capabilities and are not suitable for long-distance space travel. In order to travel to other star systems, humanity will need to develop new propulsion technologies that can get us there faster. One of the most promising propulsion technologies currently being researched is nuclear propulsion. Nuclear propulsion systems use nuclear reactions to generate heat, which is then used to power a rocket engine. This technology has the potential to greatly increase the speed and efficiency of space travel. Scientists are currently researching new ways to harness the power of nuclear reactions, such as developing new types of nuclear fuels and designing more efficient engines. Another area of research is antimatter propulsion. It is a theoretical propulsion system that would use antimatter as a fuel. Antimatter is a type of matter that is composed of particles with opposite charges to those found in normal matter. When antimatter particles come into contact with normal matter particles, they annihilate each other, releasing a large amount of energy. This energy could be harnessed to power a rocket engine, and could potentially enable much faster space travel. However, antimatter is extremely difficult to produce and store, and that's why it is still in a theoretical state. In conclusion, the development of new propulsion technologies is crucial for humanity's ability to explore and colonize space. Nuclear propulsion and antimatter propulsion are considered some of the most promising technologies currently being researched. While still in early stages of research, these technologies have the potential to greatly increase the speed and efficiency of space travel and enable humanity to reach other star systems. Space colonization has the potential to bring about significant economic and political changes. The development of new technologies and resources from space exploration could lead to major economic growth and job creation. Space resources, such as minerals, water, and energy from space, could provide new opportunities for economic development and help to solve many of the world's problems. Additionally, space colonization could lead to new forms of governance and international cooperation. The development of space settlements would require new legal and political frameworks, and could lead to the creation of new autonomous territories or even new countries. This could also facilitate the formation of international partnerships, as countries collaborate to establish and maintain settlements in space. However, the economic and political implications of space colonization also raise many questions and concerns. For example, who would own and control the resources on a colonized planet or asteroid? How would disputes over territory and resources be resolved? Additionally, the development of space settlements could also bring new challenges and inequalities, as access to space resources and technologies may not be evenly distributed. In conclusion, space colonization has the potential to bring about significant economic and political changes, but it also raises many questions and concerns. The development of new technologies and resources from space exploration could lead to major economic growth and job creation, but also raise questions about ownership and control of resources. Additionally, space colonization could lead to new forms of governance and international cooperation, but also bring new challenges and inequalities. Therefore, it's important to consider the economic and political implications of space colonization and work towards finding solutions to these challenges. Space colonization raises a number of ethical considerations that must be taken into account. One major issue is the potential impact on other life forms. The colonization of other planets could lead to the displacement or extinction of any microbial or indigenous life that may exist on those planets. This raises important questions about our moral obligations towards extraterrestrial life and the ethics of potentially wiping out entire ecosystems. Another ethical consideration is the impact of space colonization on future generations. The colonization of other planets could have long-term consequences that are not yet fully understood. For example, the development of self-sustaining colonies on other planets could lead to the permanent isolation of human populations and raise questions about the preservation of human culture and heritage. Additionally, the ethical considerations of space colonization also include issues related to the distribution of resources and opportunities. The development of space settlements could lead to new forms of inequality, as access to resources and technologies may not be evenly distributed. This could exacerbate existing social and economic inequalities on Earth and raise questions about the distribution of wealth and power in space colonies. In conclusion, space colonization raises a number of ethical considerations that must be taken into account. These include the potential impact on other life forms, the impact on future generations, and issues related to the distribution of resources and opportunities. It is important to consider these ethical implications and work towards finding solutions that will ensure that space colonization is conducted in an ethical and responsible manner. Well, that's all I have for today, guys. If you have any comments on today's episode or have ideas for future episodes, I want to hear from you. Leave a comment below, like this video and subscribe to my channel to make sure you don't miss future episodes. Until next time, Mr. Synthetic signing off.